Okay, question 5. So this is the first of the voltage divider questions in the quiz. So there's quite a bit of emphasis on voltage dividers in the quiz because they're such an important fundamental concept in the design of all the amplifiers that we use in biopotential measurement. So in this case, we're looking at a very simple voltage divider circuit. 2 resistors, R1 and R2. The values here are 5K. And, I'll just switch over to my camera here so you can see what I'm writing. So we've got 5 kilo ohms is R1. R2 is 15 kilo ohms. We're told that V in is 10 volts. And we know that the bottom node in the voltage divider here is connected to ground. So that means the voltage at this point or at this node in the circuit is pinned at 0 volts. So there's basically 3 nodes here. There's a kind of a binary node in the middle, and then there's a node at the top and a node at the bottom. And what we're interested in doing is calculating what's the voltage at this binary node in the middle here. Now you can actually see more or less straight away here that 1/4 of the total resistance is in R1. So that means 1/4 of the voltage drop from here to here will be across R1. So 1/4 of 10 is 2.5. So basically I can already see at a glance here that this is going to be 2.5 volts, but I want to work through it just carefully and methodically just in case anyone's confused about how we calculate this. So you can apply the formula here if you want, which is that you can find the fraction of the total voltage V out here is going to be equal to the voltage at the bottom node, which is actually just 0 in this case, plus the voltage dropped across R1. So that will bring you up to the voltage at V out here. So the voltage drop across R1 is going to be R1 over R1 plus R2 multiplied by the total voltage drop across the 2 resistors in the voltage divider. So that's 10 volts dropped from here all the way down to here. So this multiplied by 10. And that is basically just 5,000 over 5,000 plus 15,000 multiplied by 10, which is 2.5. In this case, that's 2.5 volts. And that is our answer. So you could go at it the other way as well to look at the voltage drop from here down to here. So you could climb down 7.5 volts from 10 volts and that will give you the same thing. You'd still come out with 2.5 volts here. So for most of these voltage questions where you're asked for an answer in volts, it'll specify here, give your answer in volts, but all you are to type in here is just the number. So you don't type in the units, just make sure that the number is in volts. And then you'll get the answer correct. So if you type in some other text into the box here, then the answer will be marked incorrect. Okay, question 6. So this is another voltage divider. So question 6, what have we got? Well, we know that V in at the top is equal to minus 5 volts. The bottom node in the voltage divider here is still connected to ground, so that means the voltage here is pinned at 0. And you're asked to calculate V out and to give your answer in volts. So as we did before, we can just calculate it using the formula. So 0 is the voltage at the bottom node, and then the voltage dropped across R1 here is going to be R1 over R1 plus R2 multiplied by V in, which is, we can see R1 here is 3 kilo ohms over R1 plus R2, that's 3,000 plus 4,000, multiplied by V in, which is minus 5. So of course this is just 3 over 7 times minus 5. So I'm going to quickly switch to octave here just to do the calculation here. Okay, so what have we got? 3,000 over multiplied by minus 5. So what do we get? Minus 2.143. volts. And that is our answer there. So that's V out, minus 2.143. I would ask that you type in all of your answers numerically with 3 decimal places. That way you should be well within the specified tolerance for each of the questions. Okay, so we just type in here minus 2.143. Okay, question 7. So question 7 is another voltage divider question. What do we have this time? Well, we've got OR1 equal to 20 kiloohms and OR2 equal to 10 kiloohms. And we can see at the top node here that the node voltage is 2 volts there, and the voltage at the bottom node is 5 volts. So this is the first example we've seen where one of the nodes isn't grounded, right? So in this case, it makes sense to start thinking of this more as like a weighted average of the two voltages here, and the weightings of the two contributions will be in proportion to the respective sizes of the two resistors. So we'll calculate V8 here. I'll just do it the same way as I did the other ones first, and I'll show you a different approach to doing the same thing in a second as well. So V8 is going to be equal to the voltage at the bottom node plus the voltage across OR1. So it's going to have to be, let's just actually label that V1 there. So it's basically going to be V out minus 5 volts. So what I got here, it's going to be OR1 over OR1 plus OR2 multiplied by the voltage drop from here down to here, which is actually going to be a negative number because you can see the voltage here is actually lower than the voltage at the bottom. So 2 minus 5, which is minus 3. So altogether this adds up to 5 plus OR1 is 20. I'm going to leave out the thousands here because it's going to cancel anyway in the numerator and denominator. Over 10 plus 20 multiplied by 2 minus 5, which is minus 3. So that is equal to 5 plus 2 times minus 3 over 3, which is 5 minus 2, which is 3. So V out is equal to 3 volts. Now that's one way of doing it. You can also apply a formula here, and I mean this will work even if one of the nodes is grounded, but it's just a different way of calculating the same thing. You can say that V out is going to be equal to a weighted average of these two voltages here. So it's going to be 5 times this resistance plus 2 times this resistance divided by the total resistance. So 5 times OR2 plus 2 times OR1 all over OR1 plus OR2. So in this case that is 5. Again, I'm just going to leave the resistances. I'm going to drop the thousands because everything's multiplied by 1,000 here because it's all kiloohms. So 5 times 10 plus 2 times 20 over 10 plus 20. So that's 50 plus 40 over 30, which is equal to 90 over 30, which is 3 volts. So same answer. So it's question 7. Okay, question 8. So question 8, again, this is a voltage divider question. What have we got then? We've got V1 is minus 5 volts. V2 is plus 5 volts. R1 is 1 kilo ohm. And R2 is 6 kilo ohms. Now you can basically see at a glance here that, sorry, I've written in 6 there. What I should have written, of course, that's 5 kilo ohms. You can see at a glance here that the total resistance is 6 kilo ohms, and therefore R1 is 1/6 of the total resistance, and the voltage drop from here to here is a drop of 10 volts. So we're going from all the way from plus 5 all the way down to minus 5. So that's a 10 volt drop. So the voltage across this is going to be a 1/6 of 10. So V3, which is the voltage at the center node here, is going to be equal to V1 plus R1 over R1 plus R2 times the total voltage drop, that's V2 minus V1, which is minus 5 plus 1 over 1 plus 5 times 5 minus 5. So that is minus 5 plus 10 over 6. Now, to make sure I get this right, I'll just flick into octave here. I think I know what this is going to be, but let's just be careful with it. So minus 5 plus 10 over 6. So minus 3.3333. So that is our answer there. So again, give 3 decimal places.